Write the equations of the lines that pass through the points. We have two different problems to do, so I'm going to make sure that we don't get them confused. There's also a couple of different methods that we could use, and I will do both methods. You can then choose the one that you're most familiar with or the one that seems easiest to you. The first method that I'm going to use is y minus y1 equals m times x minus x1. This is called the point-slope formula. And it's named that way because we have an x1, y1 as the point, and we have m as the slope. For purposes of this problem, I'm going to call the first ordered pair x1, y1 and the second ordered pair x2, y2. We need to find the slope first of all. We call the slope m, and we figure it out by taking the difference in the y values and placing it over the difference in the x values. The difference in our y values will be 4 minus a negative 6 over, now the difference in the x values, 2 minus 7. So we have 4 plus 6 on top, which is 10. 2 minus 7 is negative 5, and we discover that the slope has a value of negative 2. Now we are ready to put our information into the formula. We'll have y minus y1, which had a value of negative 6, equals m, which is negative 2, times x minus x1, which has a value of 7. That means that y plus 6 equals negative 2x plus 14. I will subtract 6 from both sides, which gives me an equation that is y equals negative 2x plus 8. So that is the equation that contains those two ordered pairs. Let's use that same method over here. We'll have y minus y1 equals m times x minus x1. Once again, I'm going to label them just so that we can refer to the labels as we need to. Let's figure out our slope by using the same formula that we did on the left, the difference in the y's over a difference in the x's. So y2 is negative 5, y1 is negative 3, x2 is 4, and x1 is 7. So on the top I have negative 5 minus negative 3, which is negative 5 plus a positive 3, or negative 2, and in the denominator I have 4 minus 7, which is negative 3, giving us a slope of 2/3. Alright, let's plug everything into the formula. We'll have y minus y1, which is negative 3, is equal to the slope that we just discovered, times x minus x1, which is listed as 7. Now let's simplify this. Y minus a negative 3 is y plus 3. I will use the distributive property, and when I multiply 2/3 times 7, I will think of 7 as being over 1. I will multiply the numerators to get 14 and the denominators to get 3. One more step is that I would like to subtract 3 from both sides of this equation so that the y can be alone. So I have 2/3 x. Now I need to deal with the subtraction. Let me do that over here. I will have negative 14 over 3 minus 3 over 1. I need a common denominator, so I will multiply by 3 on the top and the bottom. That gives me negative 14 minus 9 over 3. That's the same thing as negative 14 plus a negative 9, which comes out to be negative 23, and it is still over 3. So that means that the rest of our equation is now done. So this was more complicated just because of the fractions, but the method was exactly the same. So this equation that we just got is the equation of the line that goes through the ordered pairs 7, negative 3, and 4, negative 5. Let's do these two problems in a different way so that you have a choice. And to do that, I'm going to write the ordered pairs down again. I've got 7, negative 6, and 2, 4. And then when I do the other problem, I will have the ordered pairs 7, negative 3, and 4, negative 5. So let's move on down so that we have more room. The way that I'm going to do the equation of the line this time is to use the y equals mx plus b format to actually figure out the equation. I still would need the slope. The slope would still have the same formula as it did a moment ago, which was the difference in the y's over the difference in the x's. Since we discovered that the slope was equal to negative 2 a moment ago, I'm going to just take advantage of that. I'm also going to use one of my ordered pairs. Remember that it has an x component and a y component. So I'm going to put negative 6 for the y. The negative 2 goes in for the m here. For x, I'm going to use the 7 that's in the ordered pair, and then the only letter that's left in this equation is b. So I should be able to solve for b. If I add 14 to both sides, I end up with b equaling 8. So putting the slope and the b value into the formula, I will have y equals negative 2x plus 8. And we see that that is exactly the same equation that we got when we used the other method. Alright, let's use the y equals mx plus b to find the equation over here. Again, we need the slope, but since we already figured it out, I'm not going to figure it out again. I'm just going to remember that the slope was 2/3. I am going to use this first ordered pair for my x and y. So replacing y with negative 3, I'm on my way. Instead of the m, I have 2/3. Instead of x, I have 7. And then I have only one letter left, which is b. Negative 3 equals, now in order to multiply these together, I'm going to put a 1 under the 7, multiply across. 2 times 7 is 14, place that over 3, and then I have plus b. So at this moment, I am ready to subtract 14/3 from both sides. The fractions make it tougher, but we certainly can do this. So once more, doing the messy stuff over here, I've got negative 3 minus 14/3. I need a common denominator in order to combine them, so I will multiply by 3 on the top and the bottom. That gives me negative 9 minus 14 over 3, which turns out to be negative 23 over 3. And because I have my b, I can now use this formula by putting in the m, which is 2/3, and the b, which is minus 23/3, and that is exactly the same equation that I got by using the other method.